Hello everyone! In this lesson, we will learn the key components of industrial cameras and their working principles. First, let's learn about the CCD sensors for industrial cameras. As shown in the figure, after removing the lens, you can see that CCD photosensitive chip. The image sensor is like the film in a traditional camera. The CCD chip can convert the optical signal of the image into a digital signal. CCD means charge-coupled device. A charge-coupled device is a semiconductor component that can convert image into digital signals. A CCD photosensitive chip consists of millions or even tens of millions of charge-coupled devices, which are arranged in a grid, and each small grid represents a pixel. When taking a picture with the CCD, the light reflected from the target passes through the lens and forms an image on the CCD. When a pixel on a CCD receives light, a charge corresponding to the light intensity is made, and the charge is converted into an electronic signal to obtain the light intensity received by each pixel, which can also be called density. That is, each pixel is a sensor that can detect the light intensity. A 3-megapixel CCD is a collection of 3 mini photodiodes. Next, please answer this question. What are the main functions of CCD photosensitive chips? A. Adjust the focal length. B. Control the aperture size. C. Convert the optical signal to digital signal. D. Provide image storage. I will give you 5 seconds to think, and will show the answer after 5 seconds. The answer to this question is C. Did everyone choose the right answer? Okay, let's keep going. In many imaging systems, each pixel transmits data values in the range of 0 to 250 depending on the light intensity. When performing monochrome black and white processing, black is recognized as 0 and white as 255, allowing the light intensity received by each pixel to be converted into numerical data. That is, all pixels of the CCD have values between 0 black and 255 white. For example, green contains half black and half white, and it will be converted to 127. The image data captured by the CCD is a set of picture data constituting the CCD, and the picture data is reproduced as 256 level contrast data. Next, please answer this question. In many imaging systems, what's the data values range transmitted by each pixel depending on the light intensity? A. 0 to 128. B. 10 to 155. C. Minus 128 to 127. D. Minus 255 to 255. I will give you 5 seconds to think and will show the answer after 5 seconds. The answer to this question is B. Did everyone choose the right answer? Okay, let's keep going. As shown in the figure, there is a picture of a smiling face. First, turn it into a grayscale image, and each pixel on the grayscale image is represented by a value between 0 and 20. Between 0 and 255. If we look at the grayscale image with a magnifying glass, then we can see the specific value of a certain image area, such as the left eye area, and its corresponding area value is shown in the figure below. We can see that because in the original image, the eyes are almost black, the grayscale data corresponding to black is relatively low. The area around the eyes is gray, and the grayscale data corresponding to gray is relatively large. The so-called image processing is a processing process that calculates the numerical data of each pixel through various calculation methods so as to extract image features. For example, in stain defect detection, a detection area is divided into small areas. An average green value in each area is compared with data of surrounding areas. If the average green value of a certain area exceeds a set threshold value of difference data, the area is detected as a stain or a defect. As shown in the figure, in the example, green indicates a stain or a defect, and the average green value of the area to which it belongs must be significantly different from the average green value of the area without the defect. Next, please answer this question. Which of the following processes describes the basic method of image processing? A. Extract image features by calculating the numerical data of each pixel through various calculating methods. B. Observe the image directly and label the features manually. C. Use filters to beautify image. D. Adjust the image brightness and contrast. I will give you 5 seconds to think and will show the answer after 5 seconds. The answer to this question is A. Did everyone choose the right answer? Okay, everyone, let's make a summary. Each photosensitive element on the CCD photosensitive chip corresponds to a pixel on the image, and each pixel can express 256 green values. Through the algorithm, by detecting the changes of regional pixel positions and grid values, we can obtain various variables or features we want to meet. different practical application scenarios. Next, let's learn about the focal length adjustment of industrial camera. Focal length, also known as focal distance, is a measure of the concentration or divergence of light in an optical system. It refers to the distance from the center of the lens to the focus of light concentration. The focal length of the lens determines the size of the image formed by the subject captured by the lens on the imaging plane. On camera, focal length refers to the distance between the optical center of the lens and the imaging unit. Since the distance between the object being photographed and the camera is not necessarily the same, when the camera takes an image, in order to obtain a clear image, the distance from the CCD photosensitive chip to the optical center of the lens must be changed according to the different object distance. Rotate the focal length adjustment ring on the camera lens to adjust the focal length. This process of change is what we usually call focusing. As shown in the figure, the focal length adjustment range of a camera is 24 to 70 millimeters. Next, this picture in the local length of an industrial camera, which is 12 millimeters. Next, please answer this question. What is the lower focal length measured in an optical system? A. Speed of light. B. Wavelength of light. C. Concentration or divergence of light. D. Light intensity. I will give you 5 seconds to think and will show the answer after 5 seconds. The answer to this question is C. Did everyone choose the right answer? Okay, let's keep going. Next, let's learn about the aperture adjustment of industrial cameras. The aperture is a component on the camera used to control the aperture size of the lens. By controlling the amount of light entering the lens, it can meet the appropriate illumination required for imaging. The picture shows the aperture part of the lens. The size of the aperture is controlled by the aperture blade, as shown in the figure. Imagine that when there are no windows in the room, the wider the door is opened, the more light enters the dark room, and the brighter the room. The aperture also has the same function as the room door, except that it's only for the CCD sensor of the camera. The larger the light aperture of the photosensitive aperture, the greater the luminous flux passed through. But what we are concerned about is the actual amount of light reaching the photosensitive chip of the CCD sensor. However, A longer focal length means that the photosensitive chip of the sensor is far from the center of the lens, and accordingly, the light is weaker. So, the parameters of standard aperture size are related to two variables: aperture diameter and focal length. On the lens, we often see an f value, that is, the aperture coefficient. The f value is a parameter used to express the diameter of the aperture, and the f value is equal to the ratio of the focal length of the lens to the light passing aperture diameter. The luminous flux is inverse proportional to the square of f value, and the smaller of f value, the greater the luminous flux. That's to say, the smaller the aperture f value on the lens, we can see, the larger the actual aperture diameter. The more light enters the photosensitive chip of CCD sensor through the lens, the larger the camera image will be. The rule is that the luminous flux of the previous sun is exactly twice that of the corresponding light flux of the later sign. That's to say, if the f value of aperture is reduced by one level, the luminous flux will be increased by 2 times. Generally, the aperture can be adjusted. Next, please answer this question. The smaller the f value of the aperture, what does it mean? A. The smaller the aperture diameter. B. The larger the aperture diameter. C. The longer the focal length. D. The shorter the focal length. I will give you 5 seconds to think, and will show the answer after 5 seconds. The answer to this question is B. Did everyone choose the right answer? Okay, let's keep going. Sometimes we will adjust the aperture size appropriately according to the brightness of the light source and the actual imaging effect of the target to be seen. But it's not that. The larger the aperture, the better the image. Different aperture sizes have different image blurring degrees. As shown in the figure, it can be seen that the larger the aperture, the shallower the depth of the field, and the more blur the background of the image subject is. From this picture, the maximum aperture of Connex camera is 1.4. In fact, during imaging and the lighting process, we have to adjust it according to the actual imaging effect of the target to be seen. Next, let's look at a practical operation video. In this video, we can see that the aperture of the lens can be slowly adjusted up or down. That's because there's a rotatable adjustment ring on the lens. Here, we can also see that the maximum aperture value is 1.4. Everyone, in this lesson, we learned about the working principle and characteristics of CCD sensor, and we learned the basic concepts of image processing, which involves various processing and analysis of collected images to extract useful information. Furthermore, one of the focuses of this lesson is camera lens adjustment. The focal length adjustment is essential to ensure image clarity and accuracy. Whether in shooting cameras or industrial cameras, please remember CCD is the starting point of perceiving the world. Focal length is the key to exploring details, and aperture is the tool to control the light. That's all for this lesson. Thank you for watching.